Okay, so what I'm going to go through today is going to be looking at what fronts are. If you remember from Monday's lecture, we kind of focused on kind of looking at what air masses are, different types of them, kind of where they're found. So now we're going to be kind of looking at how those air masses interact with each other. Alright, so basically whenever we have, a boundary between these, or, it's a transition zone between air masses, we call this a front. So when we have these different air masses, remember an air mass is basically just it's a large body of air with similar characteristics kind of throughout it. So it's going to have similar temperature and similar moisture levels throughout the entire air mass. Okay. So looking at the front again is just kind of like that boundary between the air masses. And so there's normally at these boundaries we see kind of some key differences and key shifts. One of those things that we see is we call a moisture gradient. So a gradient is just looking at basic concentration. So it's going from, like, say, a very high amount of moisture to very low moisture. We also see a temperature gradient, which means, like right here, you can see there's a temperature gradient. We have our warm front on the right side, or the warm air mass on the right side, with a from 55 to 62 degrees. And then we have our cold air mass here to the left, that's 20 to 31. So you can see the temperature drops by about 25-30 degrees. So that's kind of that temperature gradient where we kind of see a sudden change in temperature. And if anybody was outside on Sunday in the afternoon, you probably would have noticed that. It was probably, I think, about 4 o'clock where it went from being really warm, and all of a sudden the temperature dropped and got really cold. A lot of times we see, weather with that where we actually saw a little bit of rain. So we're looking at the other things associated with the front is we do see a shift in wind. So it may get very, very windy. The wind may stop altogether. Sometimes it can even change directions. We have a pressure trough where there's a drop in air pressure. If you remember from the elements of weather, when we were talking about the barometer or air pressure readings, whenever we see a decrease in pressure, it normally indicates that there's storms or rain. So along these fronts, we tend to see a pressure trough. A trough is just basically something that goes down or is deep. So it's basically a drop in pressure. The temperature's going down, pressure's going down. Alright, so again, there's also like our kind of convergent boundaries where they're simply moving together or moving towards each other. Yeah, so again, the convergent boundary, kind of think back to plate tectonics. Convergent is when they're coming together. So when we're looking for fronts, then the key things we want to look at, I'll go through some quick, is we're looking for a strong temperature gradient. So it's that big difference in temperature going from a high temperature to a low temperature. So that's one of the ways in which we can find a front. Same thing with, if we're looking at the dew point. So if these were the dew points, we went from 55 to 62 and dropped. That's another indicator that there is a change in fronts, or two different fronts, or two different air masses coming together. Again, we had to look for that pressure trough or the wind direction. Basically, look for anything associated with these conditions. Okay. So when we're looking at the types of fronts, there's kind of 4 key types of fronts. So I'm going to go through probably just a couple of these today, and I'll start off. I'm just going to go through a cold front and a warm front today, and I'll continue with the stationary and occluded, as well as color things tomorrow. Okay. So the first type of front we're going to be looking at is what we call a cold front. I'm just going to come back here to the definition. So with a cold front, we can see it's noted by cold air advancing and displacing warmer air that exists. So one of the key things with a cold front is to remember the cold air is moving. So when we see a cold front, our symbol is just a kind of a blue line with the triangles. The triangles are pointing the direction it's moving, or pointing towards what we call the warm air. A lot of times we see the clouds that we see with this, or we call cumulus or cumulonimbus clouds. So remember, the cumulus clouds are those big puffy clouds that kind of extend vertically or higher in the air. Remember, it could be cumulonimbus. When we add nimbus on, or nimbus, it means as rain. So they're basically big fluffy clouds that produce rain. Normally these are at our head of the front, kind of on the warm air side, and this is where we get showers and thunderstorms. So looking at kind of a drawing or how a cold front works, so we see here this is a large cold air mass right here. So the cold air mass is actually going to be moving towards the warm air mass. And so we're looking here, this is where we kind of have that warm air ahead of the front. So we have a lot of basically warmer air here. And the key thing you see is the warm air actually moves over the top of the cold air. Sorry. So it's actually kind of pushing, the cold air pushes underneath of it. Again, this is due to, remember, density changes. So remember, I think warm air always wants to rise. So that warm air is rising, moving upwards, while the cold air is pushing underneath. And like I said, on the map, we'll actually see the blue line of triangles. The triangles point the directions it's going. So we can look at here and kind of talk about temperature and talk that temperature gradient. Let me pause here to add something in. Okay, so I just had a couple things in here real quick to kind of see the difference here. So look, if you say we're looking at like the temperature, say on the warm air side, it'd be like 57 degrees. So it's getting warmer, but not super warm. Whereas with the cold air, we see it'd be like a 35 degree air mass. So when we're looking kind of throughout this air, here it'd be 35 degrees. So it's that colder air, so it has kind of a lower temperature that's pushing into the warmer air. So again, if we kind of look back here to our types of fronts, we can kind of see, knowing what we know now about this, you can see kind of this blue line right over here, the arrow. So what we see is we actually see a cold air mass. The cold air mass is right over here, it's to the left of it. It's pushing to the right into the warmer air masses right over here. So that's kind of looking at the cold front with the display idea. Okay, sorry. So what we're looking at here is on the warm air side, normally where we see the kind of storm, due to the fact that that's the kind of warmer air can hold more moisture. As the air temperature decreases, those water molecules are going to start to coalesce and form bigger and bigger drops until eventually they fall to the ground as rain. And so that's looking at a cold front. The next thing we're going to look at is a warm front. So if we come back to the definitions, so a warm front is noted by cold air retreating from an area. So normally the cold air is moving out versus moving in. So what we see here again, it's marked on the map with a red line, and normally we have these semicircles pointed towards the cool air. So that's kind of the direction it's moving. So the cooler air would be up here, so the cooler air is retreating and the warm air is coming in. So when we look at kind of the weather with this, is we tend to see kind of overcast skies where it's kind of dark and dreary, a lot of stratus clouds, remember those flat clouds, we can get fog, and then we normally just kind of have generally rain or snow. Because again, we have those changing temperatures that's going to cause the air to, or the amount of water the air can hold to decrease due to the change in temperature. It's going to cause rain to fall. So we're kind of looking at our drawing here. You can see here's our cold air over here now. That's going to be retreating or moving away from the warm air. So as that cold air retreats, that kind of the warm air is going to kind of drop down. And we tend to see kind of right in the lower atmosphere or lower troposphere a lot of cloud development. So that's how we get kind of those dreary skies. And so we're kind of looking again at a different map here. So you see the cold air is moving away. So the warm air is kind of getting pushed actually over the top a little bit as well. But due to that change in temperature, we see a lot of just kind of flat, low clouds that can produce moisture. But again, the warm air here is kind of moving over the top of the cold air, while the cold air is actually retreating. And so if we look back at our map, okay, so again, looking at our map here, what we see here is we have our warm front in kind of the top right, or the northeast of the United States. So remember, the semicircles indicate that the direction the front is moving. So we have our cooler air to the northeast here that's retreating, with the warmer air kind of pushing over the top of it. So again, we can see here as it's kind of moving through, we get our weather, or kind of our weather patterns. With looking at those cold fronts, our cold front down here is creating a lot of rain. Same thing in the northeast here, where the cold front is producing some rain as well as snow. Okay. So I'm going to pause there. I will go through the stationary and included fronts tomorrow. Okay. So if you guys have any questions or need anything additionally, please email me. Otherwise, remember, we do have Zoom sessions on Monday, Wednesday, Friday at 10 a.m. Otherwise, have a good day and good luck.